Chapter 6, Language of Chemistry. There are a lot of different chemical compounds. And just like with people, you've got a big room full of people. How do you tell one person from another person? You know, you can't say, well, you know, I'm going to give this grade to the guy with the blue shirt, right? Because next week he might not have a blue shirt on. Maybe he will. Maybe he has the same blue shirt he wears all the time, like my son Andy. And I just literally saw a squirrel. Where was I? Names. So we use names to identify people, right? And we use numbers sometimes too, but really names are the main way we identify people. And we have different systems of naming children depending on your country and or your culture. My ancestors came from Sweden, and in the old days, they would give the son his father's name with the suffix son. And so if your dad's name was John, then your last name is Johnson. If you're Peter Johnson, then your son might be Anders Peterson, right? And girls were named after their father, but with the word daughter. So if your father's name was Olaf, then your name would be whatever, Olaf's daughter. Well, they don't do that anymore because it got really confusing, I think, you know, with modern times of people's last names changing all the time. But that's an old way of naming children. And different countries have different methods of naming their children. We have different ways of naming chemicals as well. And so we divide chemicals into groups, and we have certain ways of naming them. And that's what we're talking about in this section. Nomenclature is a system of naming chemicals. That's what the word nomenclature means. And nomenclature is an important topic. This is not one you can skip out on. So IUPAC, that's the Institute for, the International Union of Pure and Applied Chemistry. So they're the ones that, people all get together and decide, this is how we're going to do it. And then, of course, some people just do their own thing anyway. But we've got different groups. So there's inorganic compounds and there's organic compounds. We will not be talking about organic compounds in this class. That's a separate class. So inorganic is what we're going to talk about. It's divided into 5 different categories, and the rules for naming are different within each of them. And you might say, well, couldn't we just have one system for all of them? But no, we really can't. Identifying the category is critical to naming the compound. You have to know which category this chemical goes in so that you can apply the rules correctly. And so that's the first thing we learn. What do we mean by inorganic? Inorganic compounds are those that do not contain carbon, with a couple little exceptions, because there's got to be exceptions, right? Carbon dioxide and carbon monoxide contain carbon, but they're considered inorganic. And things containing carbonate ion, like baking soda has sodium bicarbonate in it, those are exceptions. They're considered inorganic. So the first category we're going to look at, ionic compounds. Ionic compounds have ions in them. And so the ionic compounds can be divided into binary and ternary. Binary means what? 2. A binary ionic compound contains 2 elements, a metal and a nonmetal. The metals form positive ions, the nonmetals form negative ions. Opposites attract. And so they stick together kind of like magnets because they have opposite charges. If you have 2 positively charged metal ions, they're not going to stick together. So that's why it's always a metal and a nonmetal. Ternary means 3. So ternary contains 3 elements, has to have at least 1 metal and 1 nonmetal. So that's one group. Another category is molecular compounds. We're only going to talk about one subcategory, the binary molecular compounds. Binary again, 2 elements. Binary molecular compounds contain 2 nonmetals. If you've got a metal and a nonmetal, it's ionic. 2 nonmetals, it's molecular. Then we have acids. Acids are always dissolved in water. If they're not in water, they're named with a different system. We call them something else. Binary acid, again, binary, 2. It's an aqueous solution of a compound containing hydrogen and one other nonmetal. All the acids that we're going to learn about have hydrogen in them, and then something else. What do we mean by aqueous solution? Aqueous refers to water, a little bit like the Spanish word agua, or you think about the aqueduct. What does an aqueduct have in it? Water, right? Well, at least we hope it has water in it. Maybe it doesn't now. Aqueous solution is a compound dissolved in water. And all the formulas of acids begin with H. So those are binary acids. Ternary oxyacid. Ternary oxyacid, 3 elements. It's going to have hydrogen, and it's going to have oxygen, and then it's going to have some other element. It's going to be a nonmetal. So this one's hydrogen, a nonmetal, and oxygen. So here is a flowchart showing how this is all divided out. Here we've got the ionic compounds. Those contain a metal and 1 or 2 nonmetals. Binary is just 1 metal, 1 nonmetal. Ternary is 1 metal, 2 nonmetals usually. Molecular is only nonmetals, no metals at all. And we're only going to look at one category, binary molecular compounds, 2 nonmetals. Aqueous acids, there's 2 groups, binary acids and ternary oxyacids. Oxy is your clue that those contain oxygen. Okay, any questions? So this is the first step in naming and writing formulas, identifying what group are these things in. So we need to identify these, and here are the choices. Binary ionic compound, ternary ionic compound, binary molecular compound, binary acid, or ternary oxyacid. So that first one, carbon disulfide, CS2. What is it? It's binary. Binary molecular. So you pretty much have to have a periodic table to look at, right? So you look at the periodic table, you find carbon, you find sulfur. They're both on the right of the stair-step line. They're both nonmetals. 2 nonmetals, binary molecular. How about lithium dichromate? Li2Cr2O7. Well, that looks like ternary something, right? Because there's 3 different elements there. Does it have a metal in it? Yeah. It actually has 2 metals in it. If it's got a metal in it, it's ionic. So that's ternary ionic. How about magnesium iodide, MgI2? How many elements?
Binary ionic.
It's binary ionic. 2 elements, so it's binary. And that first one, magnesium, is a metal, so it's ionic. If it's got a metal in it, bang, it's ionic. That's it. How about this guy? HNO3 AQ. AQ for aqueous. Ternary oxyacid. I'll call that, I don't know, TOA. We can tell it's an acid because it starts with H and it's got AQ. It's got oxygen in it. There's 3 elements, ternary oxyacid. What about hydrochloric acid? Binary acid. From the name, acids are really easy to recognize because they actually have the word acid right in their name. Isn't that good? And from their formulas, they always start with H. Any questions? So, classifying ions. We talked about this briefly in chapter 5. Positive ions are called cations, and it's not cation like short for vacation. It's cation. Negative ions are called anions. They're not anions, some relative of an onion. Anion. I'll know what you mean if you say anion, but I'll snicker to myself. So, monatomic. What does the prefix mono mean? One. And atomic refers to atoms, right? A monatomic ion has one atom in it. Single atom. It could have a positive or a negative charge. You can have a monatomic cation or a monatomic anion. What does the prefix poly mean? Many. A polyatomic ion has more than one single atom in it. It has many. Could be 2, could be 5, could be 17. I don't know any that have 17, but it could be. These are groups. Groups of atoms that are bound together, and then they have an overall positive or negative charge. So for those who like pictures, there's a flowchart showing how we divided those up. We've got cations, we've got anions, and under anions we have monatomic and polyatomic. Under cations there's monatomic and polyatomic. So let's classify some ions. Monatomic cation, monatomic anion, polyatomic cation, or polyatomic anion. Hydronium ion H3O+. Polyatomic cation. Right? PC. Positive charge, it's a cation. How about sulfide ion, S2-? Monatomic anion, negative charge. So the 2- is giving us the charge in the ion. That looks a little different from what we do in math, doesn't it? In math, you would see x to the -2 power. We don't want this to look like the variable s raised to the -2 power. So we always put the number first, and we put the sign after. And what about this guy? What's weird about that? Plus how many? +1. Why don't we write the 1? Chemists don't like to write the number 1. I don't know if that's true, but I'm a chemist and I don't like to write the number 1. So we wouldn't do that in math, would we? If something was raised to the +1 power, x to the +1 power, we'd just call it x. But in chemistry, if we had H3O, that would imply that there's no charge. So we put the charge. We always have the sign. And if it's a number other than 1, we write the number, and we write the number first. Okay, that was an aside because I don't think they really cover that in there. How about permanganate ion? Polyatomic anion. Does that remind anybody else of the word pomegranate? Stannous ion, Sn2+. Monatomic cation. So that's not so hard, is it? You're looking at the number of elements and whether the charge is positive or negative.